You ready? Okay. Thank you, everybody. Oh my God, so many people. I want to start with 2 disclaimers for this talk. First of all, my second child was born last week, so I have not been getting as much sleep. Thank you. So, congratulations to you as well. That's not the point. The point is I haven't been getting as much sleep as I would have loved to get before doing this talk. Second disclaimer, I'm a tester. I'm not a developer. So I know how to investigate things. I know how to find problems and trouble. I also know how to narrow things down, which is what this talk is going to be about. In most cases, I don't know how to fix stuff. I have the highest respect for all the developers who have to fix the stuff I discover, because they fix it all the time. So what I'm going to do in this talk is I'm going to show you how to investigate performance issues, how to narrow them down to a level where it should be as easy as possible for the person responsible to fix them to do it. But I don't show you any code how to fix that stuff. Also, has anybody been to the talk optimizing Eclipse plugins? Could you just get up? All right. Chances are you're not going to learn that much new stuff. Yeah, you were there. Thank you very much. I just realized I was there as well, and I realized, cool, that's 99% of my content. The difference is I'm going to do a live demo. So if you want to see that, feel free to stay. But I don't want to steal your time with stuff you've seen already. So feel free to leave. There are other talks going on. Still here? All right. Go ahead. Your fault. Also, if you already know jvisualvm, Eclipse Memory Analyzer, or Flight Recorder Mission Control and have worked with them, I'm just going to skip over the surface. I'm not going to go into details because somehow I don't have that much time. So if you already know all those tools well, once again, feel free to pick another talk. There are cool talks going on. Everybody still here? All right. So, in the description for this talk, I promised live demos. I'm going to have live demos. Most of it will be live demos. But I'll start with a tiny bit of theory. So, performance. The definition I found is how well is the system doing the work it is supposed to do. As a tester, I hate definitions like that. I can't measure anything here. So how do I make sure that the application I'm testing and working on is performing well? How do I make sure the system is doing the work it is supposed to do properly? There's one number which has sort of been an agreed standard, and that's 200 milliseconds. There's been lots of research in the time which users accept or which users don't notice after actions. So if you do press a button, if you do press a key and something happens within 150 milliseconds, it feels instantaneous. For mouse clicks, interestingly, that number is higher. So if you click the mouse and something happens within 195 milliseconds, you don't feel any delay. So let's round it up and we end up with 200 milliseconds. So everything that happens within 200 milliseconds after the user performed an action feels like it happened instantly. This doesn't mean that the result has to be there instantly, but just the application you're working on has to respond instantly. And that could be a progress bar going on, and then you see the progress bar for 10 minutes. You're not going to be happy about that. But it's better than not showing anything for 10 minutes. Okay, that's the theory part. Live demo. I built the best application ever, and it's an application you're all working on. It's an address book. No, you're not working on address books. As I said, I'm a tester. I'm not really a developer. I'm happy I got it working. I'm happy I got all the issues in there that I wanted to show. And I have the code up on GitHub. I'll show the link on the last slide. If you want to play around with it, if you want to try out the tools that I'm showing here, feel free to do so. Feel free to open up pull requests or help me fix the stuff I did horribly wrong. All right. The application. Okay. I told you, no, we're full anyway. So it's an address book. You have a list of addresses. You could add addresses. and addresses. I was lazy. So we had an address, here's the address. We can undo that change, and ta-da, it's gone again. Nothing fancy, not too much magic going on here. But still, that's the application I built, that's the application that's out on GitHub, and of course, hundreds of people are using it, and all of a sudden bug reports come in. And people tell me that they have performance issues. After some mailing back and forth, turns out they're using it with lots and lots and lots and lots of addresses, and using it with 1 million addresses, and all of a sudden the app keeps crashing for them. Luckily, there are online generators where you can just create lots of address data, fake address data, because nobody hands around address books. So first thing I do, I create a data file with 1 million addresses. I just open it in my application. Everything's working fine. Okay, it's looking a bit strange, but oh, all right, not responding. So we had the 200 millisecond reaction time, right? Something's happening, but now it's frozen. That's not exactly what we're looking for. So bear with me. The application is doing something, I don't know what. User feedback would be nice. It looks like the report was correct. There is some kind of a performance issue here. All right, out of memory, Java heap space. Yeah, let's look at the details. Okay. Luckily enough, whenever I'm investigating reports like those, I don't just start the application. I add 2 more arguments to the VM, which is heap dump on out of memory error and a heap dump path, because otherwise it just dumps into the application directory, which in most cases isn't that helpful, and I tend to not find the stuff. So I added a heap dump path. All right, now if you look at my hard disk, you can see, okay, there's an H profile. We got a heap dump, so what do we do now? First tool I want to show you is the Eclipse Memory Analyzer tool. Where's my mouse? There's my mouse. Would be nice if this. Okay. Please start. Okay, Eclipse Memory Analyzer. What we can do is we can just open heap dump files. That's the file we just generated. And we have to wait a bit. Progress bars, awesome, right? We get immediate feedback. One warning though, this tool eats memory and hard disk for breakfast and then has some dessert. So this is a small heap dump file, it was 260 megabytes, so that was rather quick and it's okay, because I don't have, this is my personal laptop, I don't have that much memory. At work I open heap dumps which are 4 gigabytes or a bit larger. You want to have a powerful machine for that. But what it gives you is a nice overview of the heap dump you're looking at, and if you look at it, it looks quite obvious that probably this is not our issue. So yeah, we have one massive block laying around here. If you hover over it, you get a few detailed information, and we've got 240 megabytes in one object, which is our model provider. Now, why is that thing so big? What you can do is, I told you about the sleep stuff. I'm sorry. You can look at the component, get some details. All right. And now it's already telling us that we have a case of possible memory waste. We have lots of duplicated strings going on here. And whoopsie, we can then look at the retained set of this model provider. What we see, we have around 240 megabytes of char arrays laying around, which is a bit strange. Lots of objects, so let's just look at where those char arrays are coming from. Now what we can do is we can drill down nicely. Okay, it's the jar array is the value of a string. That's not that surprising. The string is coming from an array list. The array list is an undo stack, and that undo stack is located in our model provider. Already now we know, okay, in the model provider class there's an undo stack, and that undo stack is pretty big. We might start investigating why it is that big, if we can use a bit of data structure, all the kinds of things. Then again, if we take a step back, I just opened an address book file. Why do we have an undo stack in the first place? Why do we have undo after opening the file? It's not like you want to undo opening the file. So that's the first information I go back to my developers with and say, this feels strange. What's going on here? There's this undo stack, it's pretty big. Do we really need that? And what they do is say, yeah, oops, we didn't intend for that to happen. Opening a file is a condition we didn't think about. We should probably not fill the undo stack when opening the file. So that's the first useful piece of information. Like I said, I don't know exactly in the code what's going on here, why this is being filled. I just tell them, okay, please make sure that the undo stack isn't filled while opening the file. I'll have a look at it. Mouse, all right. So let me close that again. And being the great guys they are, they provide a new version of the tool. And they tell me, yeah, we found the piece in the code where it's broken and we fixed it and everything's great. And there should be no more out-of-memory issues. So what I do, I take the new latest version, I open the file. It's pretty much like before. Somehow. What's going on there? I trust them. I believe that this is not going to be another out-of-memory issue. So what can we do now? We can use a nice tool called jvisualvm, part of the JDK. Taking a bit of time to start right now. Lots of time to start right now because the address book is killing the CPU. Come on. Yeah. Part of the JDK, you've got it on your disk already. Just look in the bin folder. There we go. I can see the splash screen, you can't. All right. What this allows you to do is just peek into running Java processes. In an ideal world, I would know the process ID already, which I want to look at. I've got 2 Eclipse processes running because I've got the Windows Firewall is blocking features. Yeah, please don't. Thank you so much. All right. I tried this before. Okay, now I can just monitor what's going on in this JVM. We can see there's quite a bit of CPU usage. It's around 40%, which means 1 core of my 2-core machine is full. And we can have a look at the heap over here. So heap idles around maximum 20 megabytes. It's, like I've been promised, it's not a memory issue anymore. Somehow we've got a CPU issue. So what's going on there? Let me get back to the slides. So there's another. So we looked at the memory analyzer already. There's more options you can start your JVM with, and that's called unlock commercial features and flight recorder. Unlock commercial features means that you're not allowed to use those flags in production without having a license. You are allowed to use those features in development mode, but I'm not a lawyer, don't take my word for it. Please clarify this yourself. Don't tell them Tobias told us we can use this. All right. So what this does is it enables the flight recorder in the JVM. And you can use another nice tool, which is Java Mission Control. I'm not that much of a command line guy. I love UI tools. That's why I love the Eclipse Memory Analyzer, because it gives me pie charts. That's brilliant. So our application is still running, still dying, still hogging all the CPU it can get. In the meantime, Java Mission Control is starting. And Windows Firewall is asking me again to allow everything. Brilliant. Okay. What we can do now, we've enabled the flight recorder. And now we once again see a list of all the running Java processes. And we can start a recording. Until you do this, the flight recorder is not noticeable from a performance point of view. Unlike other performance or profiling tools, when you run your app under the profiling tool, it really slows things down. The flight recorder is, you can basically forget about it. It's there, it's good, but it doesn't stop you from doing things. Now, you can pick different recording settings. I'll just, for the sake of brevity, stick with 1 minute. You can put lots of things you want to record. How often do you want to do thread dumps? Which kind of exceptions do you want to profile? And then you've got a pretty extensive list of stuff that you can take a look at. Since I'm a tester, I love information, I love data, I just basically enable everything and to get it as often and as quick as possible. Filter later, gather first. So everything's enabled, and let's just record. Quick look back. Oops. Demo application, still dead. Still killing my CPU. Okay. Now, let's give it 20 seconds so we get a bit of data. Okay, so either we could wait for a minute or whatever time frame we configured here and then it finishes automatically, or we can just stop the recording and get the results right away because I don't want to keep you too long. Zip. Now it's downloading the recording data from the JVM, and after a tiny bit of analysis, okay, now I've got about 30 seconds of data. As we saw in the jvisualvm already, memory doesn't seem to be the issue. So let's look at code. What code gives you is a nice overview of hot packages, hot classes. And you can already see that's SWT widgets, SW widgets table showing up. If you want to drill down further down, you can just pick the hot methods, which gives you nicely sorted the list of methods which is, the JVM spends most of its time in. In our case, we're spending 42% of the time in the SWT widgets table clear all. And then basically most of the other time is spent in get item. So something about this table is odd. What you can do is you can just travel down the stack trace. And what I usually do, I know which packages I start looking for the packages of my company. In this case, I'm looking for my demo application. That's all internal stuff. There we are. Geyer Tobias performance. And we can see what, let me just scroll this a bit. What's showing up is address list part refresh. Address list part refresh is being called by refresh UI, which is being called by the CSV loader, which loads the address book from the disk in a nice method called high CPU load for demo purposes. All right. We're refreshing the address list part 102 times. Why? We're loading the file. I mean, it's nice that the user can see immediately the table's being populated, but refreshing this 102 times seems a bit much, and in 30 seconds. And we're not even done yet because we're still stuck, still not working. At least for the user, it's still not working. If we record for an extended period of time, we can just see that this sample count goes up and up and up and up. There's methods being called all over the place. So, what I can do, first thing is I, once again, go back to the developers and tell them, yeah, if we're opening the files, we're refreshing UI, and we're refreshing quite a bit often. Is that really a good idea? Can we either make that happen faster, or can we maybe not do it at all and just refresh it at the end of the file open? Would that solve performance issues? A nice thing from the flight recorder that you get, like I said, mission control is a part of the JDK already, and it gives you nice JFR files which contain all the recording data, and you can just grab them. Don't email them, your IT department will not like you for that. They're pretty big. Put them on a shared network drive, put them on a thumb drive, just pass them over, and everybody can have a look at that without having to record and repeat what you did. Because that measurement, I already did that, why should somebody repeat it? Now, yeah, as it turns out, what happened, let me just quickly close that again. Yes, I want to kill it. It's really dead. So what had happened is that for every entry that had been read from the CSV file, the UI had been refreshed with 1 million lines. That's quite often, so that's not the best idea. Once again, my wonderful developers get back to me and they tell me problem's been fixed. This time, I asked them beforehand, yeah, but did you test it? Because you know, I put this address book there on the network share, and can you please open it and see for yourself if it works? Yeah, we did. All right. I do trust them, but they fooled me once, so I'm becoming cautious. All right. Same address book. Open it. Okay. That's nice. That's working. What did you change? Yeah, we're loading the data first. We're refreshing once. Because actually the user is not interested in all these single items filling up. We're just refreshing once. And that's it. And what we get is a quite fast, responsive address book which can cope with 1 million lines. And actually 1 million lines is not that much because, whoops, if you look at it, that's just 25 megabytes of CSV file. That shouldn't kill any application. All right. We still had the issue. We opened the file, nothing happened, and it happened for, it took more than 200 milliseconds. So my next step would have been, yeah, brilliant. Now we've got fast code. Can we maybe have a progress bar or anything to indicate to the user we're working? But first of all, the big issues are fixed. We found them. I could narrow them down to the exact location where bad stuff happened. And they could be fixed easily. Instead of just handing over, there's the address book file, stuff doesn't work, fix it. And all with tools which you can either download from the Eclipse homepage, like the Eclipse Memory Analyzer, or tools you already have in your disk, like jvisualvm or the mission control stuff. How am I doing on time? 10 more minutes. Okay. Then I could show one more little thing. I'll leave these open. Please pray to the demo gods with me because this did not exactly work yesterday evening. But I'll try again. Okay. Everything worked smoothly. We fixed all the performance issues. A new release came out. We changed internal stuff which you can't see. And all of a sudden, we get performance issues again. You open the address book and this time I can't even drag. And yeah, there we go. Not responding. jvisualvm to the rescue. Please connect to the process. because it can't be a memory issue again, right? We talked about out of memory, and we probably have even tests that make sure that this doesn't happen. Ah, come on. Yes. Now if it would refresh the UI, that would be really neat. Yeah. Okay. As you can see, once again, it's not exactly a memory issue. Memory goes up a bit. But what we can see now in jvisualvm is this blue line here showing up. Yes, my CPU load's quite high, but this is garbage collector activity. Why do we garbage collect 20% of the CPU time? This sounds strange. Once again, mission control. When you don't know what's going on, get more data. Please. All right. What's really nice about mission control, it remembers your last settings, as it should. So now it's just recording with the same settings I had before. Everything on, everything quick. Get me as much as you can. Even if that means large files that I have to hand over to developers. So let's go to 30 seconds and all right, stop the whole thing. All right, okay. This time, since I don't know what's going on, I'm just ticking off all these nice analyses we have here from top to bottom. And if you look at the memory usage, it hasn't been that horrible, but there's a nice thing you can look at down here, which is the allocations which are happening. And I'm not exactly sure why we're allocating 158 megabytes of data in 30 seconds, and why we have even 526 megabytes outside of the T-lab allocated. It's just allocations. That's not stuff we're keeping in a heap. It's just allocated, deallocated, allocated, deallocated. That's why we've been seeing the garbage collector so often. And what we can do, once again, let's drill down. And oops, what we can see is all of a sudden there's the undo elements showing up again. Let me just. So we're having lots of copy off method calls from arrays. We're expanding capacities of arrays, and that's caused because we're doing undo elements. Why are we doing undo elements again? We're opening a file. What's going on there? Yeah, as it turns out, somebody remembered that opening a file doesn't need to fill the undo stack, but they refactored stuff, and it was easier to just create a new entry in the undo stack and then just clear the undo stack. And create a new entry and clear the undo stack and all of that. So you're not having a memory issue as such. You're not running out of heap space. You're just keeping the garbage collector really, really busy, which doesn't make sense. So once again, we have a nice little talk. I pass on this JFR file and say, hey, that feels strange. Why are you creating 600 undo elements if you're just opening a file? I thought we had agreed on 0. And yeah, okay, we'll fix it. And once again, we're back to normal. The app is working. There's tons of more stuff you can look at when you're flight recording. Mission control has great charts analysis you can do. You can have a look at what your threads are doing. If you have any thread contention, if you have having locks, blocking threads, blocked threads. This thing is amazing. I can't go into too many details. Please have a look at this yourself. Just for me, it was important to show you it's easy to at least narrow down performance issues. I don't know how many of you will have to fix those, but it's pretty easy to narrow them down with the tools you have available already. Feel free to buy tools, sure, but you don't necessarily have to. And at least from my professional experience, most of the problems I'm getting reported by users, I can fix just by looking at the heap dumps I'm getting, or by using the flight recorder mission control combination, just seeing what the application is doing. Are we allocating stuff unnecessarily? Are we having hot methods which are going crazy, which we shouldn't be calling? And that thread contention is also really helpful to see if threads are hogging logs, and if you have any problems there. Is anybody blocking your main thread which shouldn't be blocking the main thread? All right, I think I talked way too fast because, let me see, I'm almost out of slides. I'm out of demo. You don't see the slides. All right. Yeah, go away. Feel free to leave. All right, like I said, for the flight recorder, you may require a commercial license if you want to use it in production. Wait a look at, you did see that. Our HR department asked me to tell you that we're looking for people. If you're looking for a Java job around here, we're really closely located. It's nice around Ludwigsburg. Feel free to talk to me or go to jobs.vector.com. Please rate my talk. If you have questions, and please don't drill me on the technical details of how all this works. Feel free to ask. And that's, if you want to note it down, the GitHub link where you can find my horrible little E4 performance problem demo application if you want to play around with the tools yourself. Thank you very much. Any questions?